All right. What do those do? Each one of those answers, what would they do? Or, I know it's a weird question, but what do those numbers mean? X-intercepts. X-intercept always makes the output 0. There, you solve it, you're solving equals 0. Yeah. So, there's so many ways to represent. If I just say find the x-intercepts, I could give you a graph and you could just point at them. There, I found it. I could give you a function and you have to set it equal to 0. Or I could give it to you already equal to 0. So they all mean the same thing. Yeah. I like it. 2, 4, 6, 8, 12, 20, 22, 24, 25. All right. We still have, what do I have now? I'm at 39 now. I'm at 39 students. So I'm just missing 14 today, that's all. That's all. I'm over half, I mean, all right. Anybody, now that a few more people came in, anybody need either one of these, either this one or this one, the updated homework?
Those ones you gave out yesterday?
Yeah. Okay. Yes.
Can I get the
Yes. Someday I'll remember to put this in Canvas. Maybe. We'll see. I'm not good about updating Canvas because I don't like Canvas. And so, okay. Anything else from homework before we get back into this here? All right. Okay.
Wait, so.
Oh.
So 78, I'm getting to the point where I'm solving for R.
All right, hold on.
It's not working.
78?
Yeah.
Well, that was the one, okay. So then you would put in there, what was it?
So I got
48
pi equals pi
R times R minus 1, right?
Wouldn't it be R squared?
R
though?
squared, yeah, thank you.
And then I divided by pi.
Sure, yeah, so they cancel.
Rid of that. And then I did 48 equals R cubed minus R squared.
Good. Then?
And then that's where I kind of got stuck.
Oh, all right, so help me out. How would you solve this? X squared minus x equals, just put something, Jeff, 30. How would you solve that?
Add the x over, right? So you can get the x squared by itself. Back.
You're always trying to get the x's by themselves,
Mm-hmm.
right? So I can't combine these. And I know you know how to do this. It's just that we got so much other shit we've learned. I get it equal to 0 and then I factor it, right? I subtract 30. And then I factor it, right?
Okay.
Blah, 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 blah. Okay. Same thing you're going to do here. It's just not as easy because the powers are higher, which is why it's in this section, because now you can use synthetic division.
Okay.
Okay. Notice you're missing an R term, right? So you're going to subtract 48. You're missing an R term, so you're going to have to put a 0 there. Okay. Is that all right? Okay. Anything else? From homework or anything? Okay. All right. Yes.
For 33, how do you get 4? Like, I got only 3 zeros, but how would I get the last 0? Because there's 4. Like,
If you got 3 zeros, you got the last one. So did you synthetically divide?
yeah.
What's the last synthetic division you did? What's at the bottom of it? So you synthetically divided by something and it worked. What did you have left here? What numbers?
1, -4, and 1, 0.
Wait. 1, -4.
1, -4, and -1, and 0.
Wait. You got 3 answers, right? So your last synthetic division, you should only have two things left. All right, so, okay. Okay, so this is a good thing to talk about right now, because I've said this, but it's I think I know what happened. So let me make a guess, and then you tell me if I'm right. Go away. Okay. Which one was it again? 33. So I'm going to give me one number that you got to work.
-2.
Okay. So everybody who hasn't done this yet, here's a little freebie for you. Isabella's done some work for you, okay? So this will work. So let's see. This one works, right? So 1, -2, -4, 8, 1, -2, 6, -12, 0. Right?
Wait, hold on. I think I did the wrong one.
Oh,
But
shit.
I'm finding those are not.
What happened? Sorry.
I think I wrote the numbers down wrong. Sorry.
Well, I think I don't know.
Yeah, because I didn't have -7 or 8. I have x4 minus 2x3 minus 9x squared minus 2x.
Oh.
I think that's on me, sorry.
Oh, that looks like it's number 34.
Oh.
Okay. All right. So it doesn't matter. It doesn't matter. If I get one thing to work, I'm not going to redo this for the next number. I'm going to do this. So if you do it, so how many coefficients did I have to begin with? 1, 2, 3, 4, 5, right? How many do I have now? 4. There's 2 more that you said you found, correct? So each time I do it, if I do another one, now I'm going to have 3. If I do another, now I should have 2 left. And if you do synthetic and you get to the point where you have like 1, -4, that means x minus 4, which means another root is 4. Do you see what I mean?
Yeah.
So if you have a 4th degree and you found 3 answers, that means you found 4. Because the last one is just sitting there waiting for you to look at it. Does that make sense? Let me lower this. You guys sort of with me? One big mistake I see people make is they'll get something to work and then they try another number, but they start with this again. That doesn't make any sense. If I'm factoring, if I get one piece that works, it just stays over here. I work with what's left over, don't I? So that's exactly what we're doing here. I'm never going to use this again in this problem because I just got it to work. X plus 2, you're done. Now I got this shit to worry about, right? Yes?
That's because it actually won't work, not just because it's like more convenient or shortcut.
It will work. It will totally work.
Okay, it's just.
But it's more work, right? Yeah. Okay. It's like if I have a big ass polynomial, blah, 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 and I get x minus 2 to work, right? I should have x to the 4th crap left over, correct? But then I go, let me get this, and let me try to see if I can make x minus 3. Why would you work with this anymore? You've already got a part of it figured out. This is what needs to be broken down. So that's exactly, why would you come back to him again, ever? You've already got x plus 2 times this, now I just gotta work on this business. Okay, good.
Okay, so what I did is, so I just want to know if it's wrong. Just because I thought what we had to do is once we found an answer, which is x plus 2, that we would use the bottom and we would use that to factor it out. So we would use like x cubed.
Cubed minus 4x squared plus
Yeah.
x
I thought
plus
we
6.
grabbed that and that we factored that and those two would be our answers.
You can't factor that. So right now we've got x cubed minus 4x squared plus x plus 6. Can you factor that? No. I have to do synthetic on it. So that's why I said I would just do another tier here, right? And then I would try a number out here. Yeah. Okay. I like it. It might be just me that likes it, but that's all right. Okay. Anything else from homework stuff? All right, so let's review what we did yesterday, and then we're going to finish this handout that I gave out, the one that's got the horizontal asymptotes little box. And then we're going to do a little bit from chapter 6. Okay. So yesterday, what the hell did we figure out yesterday? So if I had, for example, if I had this, you could do it, Jeff. Look at you go. Okay. Can anyone tell me anything about the graph of this? Or tell me what work I have to do to start to think about the graph of it. Yeah.
Synthetic division.
Synthetic division is a tool. Real quick, let me see if you guys remember this. Synthetic division, one of the main things it does for us, it's a tool for when I have something that I want to and I can't. Factor. I love it. I can factor the bottom. I don't need synthetic division's help. Right? The bottom is a kick-ass, easy shit. Yes, everybody. Right now, I don't feel any qualm saying factoring the bottom should be easy shit. Everybody, right? Okay. If that's not true, dear God, come see me. At this point, you should be able to factor this stuff. Bam, 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 bam. So how do I factor the bottom? And then what's that going to tell me? So how do I factor the bottom?
X minus 3, X minus 6.
Almost.
Plus 6 minus 3.
Yes. Bigger one's positive.
Okay.
Yeah, they got to be different signs.
Okay.
And then the big one's positive. I love it. Now, why did you want me to do that? Why did we want to factor? What does it tell me?
It tells you
The asymptote,
Which kind of asymptotes?
the vertical.
Good, the va. And then you got the ha, right? So what are my vertical asymptotes?
Positive
3
3.
and negative.
Now, everybody listen. When I ask you, for example, when I ask you for an x-intercept and you say 7, why is that sort of wrong? It should be 7, 0, correct?
Mm-hmm.
This, when I ask you for an asymptote, isn't that a line? It's a dotted line we set up, correct? So the answer to the asymptote question should be an equation of a line. And the equations of the line would be x equals 3, x equals negative 6. Okay. Is everybody with me? Okay. Does anyone remember in this case? Well, first off, is everybody really, really cool with that? Why am I going to put walls on those?
Because the bottom can't be 0.
Yeah, I can't allow the function to go through there, so I put a wall up to remind my function, hey, don't come here. You guys with me? It's got a Star Wars thing. Emperor Palpatine. Shield generator will be quite that first. Okay. So those are where I'm going to put my walls. What about horizontal asymptote? What situation are we in? Which one, the top or the bottom, has a higher degree?
Bottom.
The bottom. Does everybody understand that that means the bottom is going to grow faster? Does that make sense? If I'm squaring shit versus just letting shit be shit, the squared stuff is going to grow a lot faster, correct? If the bottom is growing faster and I'm dividing by a bigger number, my results should be getting closer and closer to 0. So the horizontal asymptote would be y equals 0. Because the bottom degree is higher than the top. That's the one horizontal asymptote we talked about yesterday, was that situation. Of course, we've got 2 more situations to talk about. We'll get there. Is everybody with this so far? Okay, maybe. Yes?
So it's 0 because that's what we're avoiding, what it can't be. That's what it's going towards.
I want this to really, I really want this to make sense. So these are places my function has to avoid because I can't plug those numbers in. If my function goes through x equals 3, that means there's an output there. Well, what happens at 3? This thing freaking becomes, what happens at 3? This thing becomes
0.
It can't
undefined,
become
right?
0.
Divided by 0. Okay.
Oh, yeah.
I like it. You guys all with me? Now, real quick, this one. Now, this is a little. All right. Anybody remember what the shit the horizontal asymptote means? That's when I let x get really big. You with me? When x gets really, really big, doesn't the bottom get stupid big compared to the top?
Yes.
So I'm dividing by bigger, bigger, bigger. So of course I'm going to go to 0 eventually. So in the middle, when x is small, anything could happen. Does that make sense? This only applies when x gets really big. So later this semester, we're going to see stuff where I have a horizontal asymptote, and I have a function that does this. Doesn't it go through it
Yeah.
an infinite number of times? But
Well,
isn't it
looks
getting?
like it's going through it, but it's really going around it.
It is going through it. It totally is going through that dotted line. It totally is going through it, correct?
It's like an oscilloscope, you know?
Exactly. So later this semester, we're going to talk about the functions that give us pictures like this. I can go through a horizontal asymptote because when do horizontal asymptotes kick in? When x gets really freaking big. You all with me? And all this function has to do is as I get bigger, my outputs have to approach it. That's all they have to do. So I can approach it like this, like when I pluck a guitar string. Thank the gods, it kind of dampens over time, or else every guitar string would still be playing right now that's ever been plucked. Are you guys? When I pluck a guitar string, doesn't it eventually become quiet?
Yes.
So then the sound wave would diminish over time. You guys with me?
Mm-hmm.
That's what that is. So isn't it approaching 0 over time?
Yes.
Thankfully it gets there. Or else again, every guitar would still be playing right now. Yes?
So it's not always 0 though?
Definitely not. Why is it 0 in this case? Because the bottom degree
It's bigger.
bigger than the top.
So
We still have to talk about if they're the same. And I did mention really quickly, but we're going to talk about what if the top is bigger, correct?
but every time the bottom's bigger?
Every time the bottom degree is bigger than the top, y equals 0 is going to be what it has to approach eventually. In the middle, it's sort of like end behavior. It's exactly like end behavior. We know what happens at the ends. What can happen in the middle? Weird shit. But the ends, something definitive has to happen. So this thing, at the ends, it should be approaching it. So I could have a function, instead of doing this weird shit, it could just do this. Let's see. There we go. It could do this. Waha. I can't do that, Jeff. Try again. It could do this. Waha. And it could do this. Wee-hee. Right? So as x gets really big negative, as x gets really big positive, it just has to approach that. But in the middle, I can just ignore this stupid thing because it only kicks in when it gets really big. Yeah.
Sorry, so when you say y is 0, is that like this? Like y is
Yes.
0? Okay.
This is going to be a note you want to write down. What's the equation of the x-axis? The x-axis has an equation. What is it? Give me a point on the x-axis.
0.
A point on the x-axis.
3, 0.
3, 0. Give me another one. 5, 0. Give me another one.
12, 0.
What does every point on the x-axis have in common?
0.
Be more specific.
Y is 0.
Y.
That's the equation of the x-axis.
Mm,
Do you guys get that?
yeah.
All equations do is they tell me the relationship between the x and y parts. Y equals 0 means x can do whatever the shit it wants to because it's not even in the equation, but y better be freaking 0. So what's the equation of the y-axis? X equals 0. Yeah. So y equals 0, I would put an asymptote here on the x-axis. Do you guys get that? Okay. Yes.
So you see how the denominator was, you were able to factor it? What if you can't factor the denominator?
So obviously in real life, anything could happen. And trust me guys, in real life, and not like everyday real life. I had this one kid that I would always say, how does this help me buy letters or something stupid? I'm like, how does playing a guitar help? I mean, shut, right? But in real life, when you're analyzing weather patterns, when you're doing some kind of scientific analysis, whatever, you can get an equation like this, and there's no reason that that should factor. In which case, we would obviously use computer programs to analyze it, correct? Mm-hmm. So why do we do all this if in the future we might use a computer program? Because those computer programs have to be programmed. Also, the people who use them need to understand when they give us false results. We have to kind of have a feel for things. So that's why the hell, as humans, we want to know what the shit's going on so that they don't take over. Right? So I'm trying to gird us against, Skynet is my main job. Okay.
So would you use synthetic division if
So, yeah, okay, good. So I thought you meant if it's completely not factorable, right? The ones we're going to see are obviously going to be factorable. There could be some that you have to use synthetic division on, definitely. So if I see a cubic, I might be able to do grouping, and if I can't, synthetic division. Now it's a tool. Synthetic division is now a tool we got. And it's used for a lot of shit, but what's the main thing we're worried about?
Factoring.
Helps me factor when I can. I love it. Yes?
Okay, this is probably stupid, but if the numerator had a bigger degree, would we do synthetic division? It would make sense, right?
If we needed to, again.
Okay.
If the top was x cubed minus 2x squared, I could factor that. I don't need synthetic help, right? So it's only synthetic is just a tool when I can't. It's just like quadratic formula. What is it? Primary purpose. When I can't factor something equal to 0, I could use quadratic formula, right? So synthetic is sort of like just the next kind of level. Yeah.
Why are there two vertical asymptotes?
Oh, because there's two things I'm not allowed to use.
Right, so we would do two dotted lines?
Yeah, I want to make sure you guys understand. This picture was just an example. It had
Oh,
nothing to
okay.
do with that problem. I'm sorry. So, for example, right now, what can we put on our graph from what we know?
X equals 3 and x equals -6.
Yeah. Also,
Y equals 0.
y equals 0. Now, real quick, I'm about to draw some shit, and they're not necessarily the answer. I just want to see if you understand why they make sense. What could this look like? Do you see I have all these walls?
Yeah.
Do you see I have regions I've kind of cut this up into? So for example, this could look like this, yes?
Mm-hmm.
Or it could look like that. Is that cool?
Mm-hmm.
How would I determine which one it is? Well, I would just plug a 4 in. If it's up here, that's what it looks like. If it's down here, do you guys see that? Does
Yeah.
everybody understand?
Oh.
Those are the only two options for that region over there.
So you would plug
Right?
in.
Why? Because it's got to approach this wall
Uh-huh.
and that wall. Or I could do it this way. Approach that wall and this wall.
So you would plug in a 4 into the
So let's see. What is f of 4? Uh-oh, you're not going to work, Green. Go away. What about you? Yeah, you work. What is f of 4? Somebody help me out.
4 minus 2.
So I think I get 2/10. Is that cool? 4 minus 2 over 4 minus 3. So it's 2 over 1 times 10. So 2/10.
Mm-hmm.
So it's actually, let's be more specific. It's actually, so f of 4, I haven't made this scale yet, but let's just put that there. Why not? It's actually 2/10. So it's like this.
Okay.
Okay. So again, I tried to prep you for this when I had you graph things and I said find 2 more points to help you. That would be an example of another point to help me figure out, is it up here or is it down there? Now this region, couldn't the same thing happen?
Mm-hmm.
When we just plug in a 7 or a -7 to see where it is? It's either going to be this or it's going to be that. Is
How
it?
does 2/10 tell you that it's up there though?
It was positive.
Oh, just because it's positive?
And well, how do I know it doesn't go down here?
Because it can't cross
Because
the
it
line.
can't go through the asymptote.
It could go through the asymptote.
Oh yeah, it can go through
But
the Y.
there's no x-intercept for it to go through, yes?
Yes.
Actually, I haven't talked about that yet. I know that there's no x-intercept, but what is the x-intercept? Sorry. That's another thing you could have told me that you could tell. What's the x-intercept?
2, comma 0.
Good.
How do you know that?
Sarah's like, let me just humor this guy. How do I know that? What do you mean, how do I know? How do I find the x-intercept always?
Make
Oh yeah.
x.
Make the output,
Or make y 0.
make y 0. So another way to say it is make the output 0. What's the only number that makes this fraction 0? That's the only way a fraction can be 0, is if the top is 0, correct?
Mm-hmm.
So there you go.
Okay.
Yeah. So if the top was a quadratic, I could factor it. I might have more than one x-intercept, correct? The same way you had more than one vertical asymptote. Okay. Yes.
So instead of on the sides, could it be like in the middle?
Well, it's got to be in the middle. It's got to exist in every single one of these. What are the only x values this has no output for?
3 and negative
Oh, yeah.
6.
So let's see, real quick. Somebody help me out. What is f of -7? Does everybody understand why I want to do f of -7?
Yes.
It's
Yeah.
exactly the same reason we did f of 4.
Uh-huh.
Because it could either be here, so if the output's positive, it's here.
Mm-hmm.
The output's negative, it's there.
Mhm.
You guys all see that. I need you to see that there are limited possibilities, which is awesome. Yes.
So we can plug it into the factored version. That's fine.
Shit, yeah.
Okay.
Because
I
the
was gonna say
factored
it's much
version
easier.
is the same.
Oh,
And I agree.
obviously.
Much easier to
Yeah.
look at that than to do this, yeah.
Mhm.
Not much easier. So -7 would be -9
9.
over -10 times
1
-1.
or negative.
So there's 3 negatives, so the answer is negative. -9/10. -9/10 is almost 1, so let's see. So then I know it's like this.
Okay.
Okay.
Nice.
Yes.
Can you determine like the?
We're not done, by the way, right?
Okay.
Because it exists for every other x, so it's got to exist in the middle. So
What's
the
the
question
next
about could it, it has to. It has to, because what are the only 2 x's where it doesn't exist?
Oh, right.
3 and
Three.
-6,
Oh
right?
no, I had a question about like
Sorry,
you can tell like the shape just from the slope, if it's a negative slope or if it's a positive slope.
How can you tell the slope?
Um,
Look at
It's
this.
like
Look at this
negative?
function. Is this linear?
No.
Now, is there something we could do to determine what this guy's slope is everywhere? Yes.
Yeah.
Is it easy?
No.
No. So one of the first things you learn in calculus is how to figure out the slope of anything. Right now, we only know the slope of a line, and why is that not? Well, I don't want to say it's a little evil. That's good. It's not very impressive because the line slope never changes, correct?
Right.
So if I know it's 5 here, it's still 5 there. What about a function like this? Does it have a constant slope?
No.
What is the slope right now? Positive or negative?
Positive.
And then it's 0, and then it becomes.
Negative.
Do you see? At every point the slope is changing. I'll stop. That's one of the first things you learn in calculus is how to extend the idea of slope to things that aren't straight lines. So right now we can't do that. Where did I stop? Okay.
You
So
gotta do the middle.
yeah, the middle. What's the y-intercept? That's the other thing we haven't figured out yet.
Oh.
It's easier to look at the original now. You just cover all the
Yeah.
x shit, right? What do you get?
2.
is it 1
Oh,
9 1 9?
1/9.
Wait. Oh.
So it's at 1/9, right? Which is like right there. Right? Are there any? Oh, where's the x-intercept?
2 0.
2 0.
There. So let me see if you guys. All right. In the middle, it could either do this. We kind of did this yesterday, or it could do this, or it could do this, or it could do this.
Yeah.
We actually have enough information now to do a nice rough sketch. In fact, I normally restrict the number of points you guys can plug in because I don't want this big ass XY table because then you're not applying concepts. You're just plotting points and connecting it, right?
Right.
So I wouldn't let you do any more points. You could actually figure out the shape of this thing right now.
So just have to go through both?
Could it go here?
No.
No.
Why?
No.
Does everybody see why not?
Because there's no x-intercept.
There's no
Yeah.
x-intercept back here.
Yeah.
So what's it got to, doesn't it have to do this then? It's got to approach that, and it's got to
Uh-huh.
come over here. And then it goes through. Why does it go through? That's a good question,
Because
Jeff.
that's an x-intercept.
What's the multiplicity of
It's
this?
a door.
What's
there's
the
no other
multiplicity? No, what's the
So one.
multiplicity of this?
One.
One. So
which
it's gonna
means
go
it
through.
goes
Oh.
It could have turned, right?
Oh, yeah.
Okay.
Okay.
By the way, when I give you a problem like this, there's going to be A, B, C, D, E. A would be find the intercepts. B would be find the asymptote. See, right? I'm going to step you through all the stuff, and then you just have to take that, put it on the graph. Yeah.
So when you want us to graph it, because I noticed you just like drew like the outer ones. You just drew it. You didn't like do other points. Is that okay?
Totally. What I just said. I want you to apply the concept. So the concept here is when I have an asymptote, my function has to approach it. So then I know what the shape would be. We plugged a point in just to know what side I'm on, and then I should be able to fill in the shape based on the concept that I have to approach the asymptotes, right? Now I sometimes will get somebody, bless you, I'm not even sure how to show this. They'll do something, I don't know, they'll do something like this or something. Why is that obviously wrong?
Doesn't have to approach.
Because it's not like approaching.
What does it not pass? Vertical line test.
Oh, yeah.
Yeah. Okay. I don't know. It's not maybe that, but it's something like that. Everything you draw here must pass the vertical line test because this bad boy is a function. Yes.
Why did you use 4 and -7?
Yeah. Why the hell did I do that? Well, where was the wall at? This wall. Where is it?
3.
3. And I need to know what's happening on this side of it. So I just picked 4. You could have picked 100, but you know, yeah. So you need any point that's up here just to tell, is it up here or down there? Same thing back here. This is -6, so I just picked -7. Okay. So I wasn't actually planning on doing all of that with this problem, but I love all the questions. So let's come back to this handout. Let's do one side together, and then I'm going to unleash you on the other side. Yeah, I love it. Beautiful. This is perfect. Okay. Good job, Past Jeff. Let's see if my graphing rational functions, yes. Section 5-6 it says. So this one.
Oh, I lost that. Yeah.
Thank you.
Everybody else good? What are you doing there, little dude? Okay. Look, it's doing well today. I like it. I'll tell you what. Try to do A and B, and then I'll catch up to you. C is new. We're in a different situation. Sure.
Oh, was this from that paper?
Sorry?
The one we just did, was that from this paper? No.
This is a
Oh.
brand new thing. Yeah. Hopefully everybody's got it because this is my last one. Okay. Everybody has to have it because I print out more than I have people. So pretty much x-intercepts comes from the top, correct?
Yeah.
Vertical asymptotes come from the bottom. I always get people mix those two and they have way too many walls or something.
So verticals from the bottom.
Yeah, vertical always comes from what's not in the domain. We got to put a wall there, right?
So do we have to write like x equals for the asymptote?
Totally. So if I were you, the very first thing I would do is just completely factor this thing.
Factor the tops.
Is that cool? I skipped a step there. You took a 3 out. You're left with the difference of squared. What'd you guys get for the x-intercepts?
1 and 4.
1, 1.
All kinds of things. Wait a minute. So, yeah. So I agree with x. No, x-intercepts. You're right.
Oh, okay.
I'm not sure. Okay. Is everybody cool with that? These are my x-intercepts because that's what makes the top 0, right? Is that cool? The only way to make a fraction 0 is if the top is 0, and that's why when I ask you for x-intercepts of a fractional function, you just look at the top.
And you can't do that to the bottom.
The bottom is going to lead to my what?
Oh.
Asymptote.
Vertical asymptotes. Because that's where I have to put walls and say you cannot go here function. Okay. What about the y-intercept?
1/2.
But isn't the
Or
x the
half.
bottom?
Sorry?
Isn't the x supposed to be the bottom?
No. If the bottom's 0, it's undefined.
Is a fraction.
But that one.
What about it?
The bottom.
Vertical
that's-
asymptotes.
We got the vertical asymptotes.
Vertical
from
asymptotes
bottom.
from the bottom. We haven't talked about the vertical asymptotes yet. Where did we get the x-intercept from? Top.
Oh.
Yep. Okay.
Gosh, we're talking about the intercept. I'm sorry.
You're okay. Y-intercept is always easier to look at the unfactored version because you just have to do this, right? All the x's go to 0, correct? So what's the y-intercept? Half. 0, 1/2, okay. So we've already got some anchor points.
There's no ha, right? Just like asking because like.
Oh, there will be. It's just a situation. That's why I didn't say do part C yet. It's a situation we haven't talked about yet. But you could do part A and B. It's all same old stuff. So now, what's the vertical asymptotes?
-3, 2.
Yeah, x equals -3, x equals 2. I love it. Is that cool? Okay. Yes.
How'd you get a half?
Oh, if you put 0 in for x, and then you just, yeah, okay. So factored form, it's easier to do some things, but y-intercept, it's almost always easier to do it in the unfactored form. Yeah. Now, let's talk about the situation we're in for the horizontal. Are we in the situation where y equals 0 is going to be the horizontal asymptote?
No.
No. Watch this. Are either the top or the bottom, are either one of them growing faster than the other one?
No.
Not really. They're both squared, right? So they're kind of keeping pace. Let me ask you this. All right, I just made a decision. Sorry. There's always so many different ways I could explain something. So let me write this down. Yeah. All right. So remind me, horizontal asymptotes only kick in when x gets really big, negative or positive, correct? If x gets really big, can somebody give me the biggest number you can think of right now?
Million.
Now raise that to the millionth power. Is everybody with me? Do you understand?
Uh-huh.
So when x gets really big, now go with me. Here comes the Bill Gates thing, right?
Oh gosh.
So if one of us dropped $3,
Oh yeah.
I don't want to make assumptions. If I dropped $3, I would scramble for that shit. Got to get that, man. And again, if Bill Gates dropped, he probably would pick it up, but would it be that important? No. So when x gets really big, and I mean a million to the millionth, to the millionth, to the millionth, to the millionth, to the millionth power. That is a number, and that is a kind of big number. How important is -3?
Not at all.
Not at all, right? Down here, when x gets really big, again, x is getting big too, but x squared is outpaced. So a million to the millionth squared versus a million to the million. They're both big, but this bad boy is huge, right?
Plus that one's taking away the 6.
Exactly.
That, yeah.
So that doesn't matter worth shit.
Oh.
Neither one of these
Yeah.
matters. You with me?
Uh-huh.
Does that make sense? So when x gets really big, that's what I really have. So let's do that a different way. Take your calculators. I don't know. You don't really need to borrow one, I don't think, but if you want to, you can.
Do we need one of the graphing ones, or can we use our phones?
You could use your phone, maybe.
Maybe.
So what I'm going to do, so let's try, something's not even that big. Let's try 10,000, okay? So what I'm going to do is, I'm going to put 10,000 into this equation, right? 3 times, and then I'm going to do it a better way, but I'm going to just do it directly like this. 3 times 10,000 squared
Oh, see, I can't do that.
minus 3. Now, do you see how I put the top that in parentheses? You with me? Make sure that's in parentheses because I need to tell the calculator that's the top, divided by parentheses 10,000 squared plus 10,000 minus 6. I'm going to make a prediction. I'm going to predict it's going to be almost 3. Maybe it's going to be exactly 3.
Wait, sorry, why are we using 10,000?
I just picked a really big number.
Oh, okay.
And 10,000 is pretty big for most of us, correct?
Mm-hmm.
But it's nowhere near big compared to a million to the million, but it's still pretty damn big. Let's see what we get. That's pretty damn close to 3, correct? Let me show you 2 things. One is new and the other one's a reminder. One really nifty button on here is this one. Stow. So short for store. Watch what I can do. Let's try a bigger number. Somebody tell me what number you want to use.
2 million.
2 million, okay. So everybody go hit the X button. See the X button right here next to alpha? I'm sorry, don't hit that yet. I got that backwards in my head. If you hit it, delete it. Put 2 million. Right? 2 million. You with me? Store it in X. So it should look like that on your screen.
I want to see what it's gonna do.
You guys see that?
How do you store it?
There's stow button.
Stop.
So I'll do it again. 2, 1, 2, 3, 4, 5, 6. That's 2 million, right? Stow in X. You could actually use any letter you want to. See all the green letters on mine? I don't know what the color they are on yours, but you could actually, it's alpha anything and put and store any number in any of those. They're all memory locations. The easiest one to access, though, is just the X button always. So now X has that in it. So watch what I could do now. I could just plug the damn thing exactly the way it looks. 3x squared minus 3 divided by x squared plus x minus 6.
It's even closer.
Even closer to 3. So can we make a prediction? As x gets really big, this function has to approach 3. Yeah. And let's say again.
How come it's 3?
Well, all right, I'll take you back to what I was saying earlier. When x gets really big, does -3 matter? What about x in -6? What does that reduce to? 3. So here's the cool thing. When the degrees, guys, when the degrees are the same, the horizontal asymptote is y equals the ratio of the highest degree coefficients.
So if there was no 3, would it just be 1?
Totally. So, oh yeah, the other thing I want to show you is, well, I'm not going to do it. Remember, you could put that into here, and you could use the table. And you could feed into it 1,000, 10,000, a million, a billion, whatever. And you can see it slowly approaching 3, right? So if I have this, the horizontal asymptote is y equals 3. I can just see that because it's 3 over 1. So what would it be if I had this? What do you got, Jeff? 4x squared minus 6x cubed. I'm going to try to trick you. I'm trying to trick you right now, everybody. Pay attention. I'm trying to trick you because I'm evil. Do the top and bottom have the same degree? Try again. Do the top and bottom have the same degree?
No.
Try again.
Yes.
Yes. So I'm sorry. Everybody said yes, you're fine. Isn't the top third degree?
Yeah.
Isn't the bottom third degree?
Yeah.
Okay.
it would be
So what's the horizontal asymptote?
6 over 3.
-6 over 3 is?
-2.
There you go. There would be a line at negative.
That's only if they're the same.
Only if they're the same degree.
So then ours is 3.
Because the x squared pieces are keeping up with each other, but the top is always 3 times that, correct? So that's why in the as it gets really big, they're going to divide out to be close to 3. Why not exactly 3? Because these other things, they still do a little bit, right? Okay, maybe.
Is that
Okay.
supposed to say y equals 3? Okay.
It looks like y equals sideways.
All right.
Cube.
So that's 3 in Jeff speak. Okay. All right. English is my second language. Math is my first language. Okay. I can't even do math. That's doesn't even work, Jeff, as a joke. Okay. All right. So let's come back to this sheet, which I have buried somewhere there. So horizontal asymptote, we now know that that is y equals 3. Because we're in this second situation. Now let me interpret this. Do you see how this says the top degree is n, the bottom degree is m? Is that cool? Like you just saw, some evil book or person could give it to you out of order, find the highest degree, correct? Then the horizontal asymptote is the ratio of the coefficients of the highest degree terms, just like we just did. Is that cool? Why was it 3 here? Because 3 over 1. Those are the highest degree terms, the same degree. That's the asymptote. Kick ass. Okay. Now, real quick, just take a minute and figure out what those two are. I'm going to normally be kind of nice to you. Well, no, let me not say that. I might be kind of nice to you and tell you what to use. Just find the f of negative 4. Yeah. Is about 6 point something. .42 roughly. I'll say 4.3. I don't know. You guys can do that division. 45. Oops. Divided by 7. 6.43. Hey, look at me go. Is everybody cool with that? I plugged it into the factored form, right? That's what I did. If I plug a negative 4 in, I get 3 times negative 5 times negative 3, right? Over negative 1 times negative. Did I do that right? So it's supposed to be a 6, Jeff?
Yeah.
You're all happy about doing this when you can't even do that. That's funny. All right, so what should you get? You should get 45 over 6, which reduces to 15 over 2, which is just 7.5. That's better. Is that what you guys got?
Mm-hmm.
Okay, I got you. Don't hesitate. It's fine. I'm doing a lot of shit in my head. And I can do a lot of shit in my head, but it's also easier to make a mistake. So if I make a mistake, just call me out. Not a problem. So that one I just had trouble like subtracting 2 from negative 4. That's pretty bad. Oh, I'll get over it. F of 3, that would be 3 times 2 times 4 over 6 times 1. These cancel, so I just get 4. That's nice. So I know the graph goes through negative 4, 7.5, and 3, 4. That's nice. That's good to know. How's everybody doing so far? So let's try to plot everything in. The last thing you're going to do before you actually start making your graph is figure out the y-axis. But now I've got everything I need. Now I kind of know what to make my y scale. I know my y-intercept's pretty small. These don't get too big, but I definitely don't want to use by ones, do I? Because then I couldn't give this point, correct?
Yeah.
So make a good scale. You should never have to draw shit off here. Never. If you start doing that, go, wait a minute, let me just make my scale better. Because you can control your scale. Real quick, if I make this go by 3s, and I'm not saying we will, if I do, does this have to go by 3s?
No.
No, good. Some of you guys seem to think that, which makes a lot of your graphs look really weird. Okay. What scale should I use on this, maybe? The highest thing I got to get to is 7.5.
Maybe like 2.
2. I like it. 2, 4, 6, 8.
Oh, yeah.
Negative 2, negative 4, negative 6. And all my x stuff involved, the lowest I see is negative 4. Everything else is pretty, right? My intercepts are there. So if one of the intercepts was negative 9, I would obviously have to make my x scale. Be careful. You guys see what I'm saying? But every single x value that I want to plot, the most out one is 4s, negative 4. So I can just use by ones. Does everybody see the consideration?
Mm-hmm.
How to figure out what scale to use. Okay. So now I can just throw everything on here. So let's see. Try to draw your vertical asymptote walls, right? Why not? Let's see if it shows up here. So I got one at negative 3. Yeah. And I got one at 2. And then I've got my horizontal wall. Got to be a little careful, right? 3's in the middle of those two. You can maybe make it in the middle. I got close. So now do you see, this is I'm sorry, let me stop. What's up? I see some pained faces. What's up? Everybody all right? You're all like, this is my resting pain face in this class, Jeff. So just deal with
Where'd you get your negative 3 and your 2? That asymptote one?
from the very beginning, right here.
Okay.
Is that cool? So I'm just going back. I'm putting a wall here. I'm putting a wall there and there. I can plot my intercepts now, right? I got an intercept at 1, 0, and negative 1, 0. I've got an intercept at a y-intercept at 1/2, which will be a little bit hard to get to, but there he is. What are the multiplicities on my x-intercepts?
1.
So what's it going to do at each
It's
x-intercept?
gonna go
Through.
Through.
Can you see what the shape is going to be in the middle then, what it has to be? It's
Upside
going to look
down.
like a parabola. It will not be parabolic, but it will look like a parabola.
Oh. Oh yeah, because then if it was, that would have to be a 2, the middle one.
Well, another thing you can learn in calculus is called curvature. So parabolas have a certain type of curvature, and this will have a very different one. Because parabolas come from highest degree 2. In this equation, I know it looks like it's 2, but it's got a lot more going on. It's not going to be perfectly symmetric here. So let's see what we got. So does everybody see that it's got to be this? It's got to go through the intercepts, and that's the y-intercept up there. So that's the only thing it could do. There's no way it can kind of come back up to there. Now, which regions do I not know shit about?
The outside.
Yeah, the left and the right regions, right? But do you see why I told you to choose these?
Yes.
3. So it could be here. How do I, even if I didn't do this point, why couldn't it possibly be here? Why could it not be here?
I know.
What would have to exist for it to be here?
Oh, an X.
Oh,
And is there an x-intercept here?
No.
no.
So you actually, sure,
Actually.
you actually already knew that it couldn't be here. But this just confirms it. 3, 4. Where's 3, 4? 3, 4 is there, so it's there. Wow.
Oh.
Now, do you see something very similar happening over here? It can't possibly be
Yeah.
here. No intercepts. But let's see. Well, what did we get? -4 went to 7.5. So 7.5 is right there about. So then it's got to look like this. Whee.
And it has. Oh. How do you know if it's. Never mind.
Okay, I can do that.
That's where the S comes from.
I really, it's very limited in the shapes it can take on, because if you try to do other things, it won't even be a function.
Right.
So it's got to always, it can't come back on itself. So it has to go up against this wall, and then it's got to eventually approach that wall. So that's pretty much the only shape it could take. I just, when I get the point, I can see if it gets really low, or see how this one got really like low, and this one sort of didn't necessarily. All right, and then of course you got the ultimate thing. You can always just plug in. I'm going to do this real quick. Actually, no, it doesn't matter. We'll do this one here. 3x squared minus 3 divided by x squared plus x minus 6. Zoom 6. Oh, I got some statistics. Don't worry about these little things. Those are stat points. Let me turn that off. Sorry.
I know.
All right. Now look, compare. You can see even better. Can you
Yeah.
guys see that's not a parabola?
Yeah.
It's not symmetric.
Mm-hmm.
It's pretty close though. So if you call it parabolic, I totally get you.
And the
I would
left-
call it
left side's a bit higher than the right side.
Yeah. See, it doesn't quite come as deep.
Mm-hmm.
So I mean, this is perfectly fine. Is it exactly like this? No, and I don't want it to be, because then that means that you just copied the damn thing. Yeah.
Is it like that because like way later on it approaches it closer?
Oh, here? Yeah.
Yeah.
See how this point's way up higher, so it just doesn't get there as fast as this one does.
Okay.
Yeah, but they both eventually. Now watch what I could do. What was the the horizontal asymptote again? 3.
Yeah.
So I can actually put y equals 3, and let's see. Now look what's really interesting over here. Do you see how it goes through?
Yeah.
Yeah.
Okay, now watch. All right, so remember what I said. Is x really big here yet?
No.
No.
Hell no. Now let me focus on this for a minute. I was kind of hoping this would happen. This is perfect. This one totally does. Now look, us, what did we do? We did as much as we knew. Are you with me?
Yeah.
Yeah.
All right. There's no way we would know ahead of time this is going to go through. So I would definitely, if you do that, I know it came out of your calculator, not from you. But let me. You don't have to necessarily do what I'm about to do. I'm going to look a little further up. So I'm going to make my x max go to maybe 40. And then I'm going to do one of my favorite things. I'm gonna do, let me see if I can make this do what I want. I'm gonna do zoom box. So you guys don't, I'm gonna do this a little quick so you guys don't have to do this. Enter, I'm gonna make this long, skinny ass box. Okay, let's see, that might be too much. It doesn't matter, Jeff, let's see what happens. Can you see, it goes through, but then look what it's doing. It's
back
getting
up.
closer to it, right? That's all it needs to do. That's all it needs to do. So the one I showed you, it went through an infinite number of times. I don't know if you guys are cool with that. It goes through an infinite number of times. It's just always getting closer. That one went through once, and then it's like, oh shit, I got to get close to that.
But I thought I can't touch
The vertical
I can't touch
asymptotes,
the vertical.
the vertical asymptotes will say, you cannot exist here.
Okay.
The horizontal asymptotes say, would you please get close to this at the ends?
Yeah.
So what can it do in the middle?
Anything.
Anything it wants to. In fact,
Okay. Yeah.
it's almost unfortunate this didn't happen, but this totally in the middle, it totally could have been like this.
Mm-hmm.
And it would have went through those lines, and why would that not matter? Because it's not big yet. X is not big there. Okay, maybe?
Mm-hmm.
Okay. Third. All right, in the interest of time, yes. Of course. We're gonna do this one together, but I'm gonna prompt you a lot, obviously. On the back, there's another one. How would I find the x-intercepts?
Factor.
Factor what part?
The top.
Top, right? And in fact, I mean, you could just factor both. That's your very first step, which is normally what I do. So how do you factor the top? Does 16 come out of 24?
Oh, I don't know. 8.
8.
Two. X plus 3.
Okay. And on the bottom, yes.
So like, I found like different numbers to factor the top with, but if it's different numbers, are we still gonna get like the same graph?
Well, the funny thing is, you don't necessarily have to factor the top because you could just set it equal to 0 and solve.
Yeah.
If you factor out the GCF, can you guys, have we done enough stuff for synthetic stuff that you can see what would make that 0? No? Okay. What would make that 0?
3/2.
-3/2. So I already know the x-intercept is -3/2, 0. And if you just set 16x plus 24 equal to 0 and solved, you'll get -24/16, which reduces to -3/2. So both ways are fine. The top is linear, so I don't technically need to factor it anyway, but still. And then how do you factor the bottom?
Plus 8 minus 3.
Yeah, +8, bigger one's positive, so the middle comes out positive. Now the y-intercept is kind of nice, and again, what do you look at for the y-intercept? What's easier?
The bottom. Or the factor.
The first piece, no, the unfactored. If I make x 0, I just do this. So what's the y-intercept?
24.
No,
-1.
-1. 24 divided by -24, correct?
Oh.
If I make all the x's 0, I'm left with 24/-24, which is -1. Okay. What are the vertical asymptotes? Be more specific.
X equals -8. X equals 3.
I like it. I still appreciate the answers. I'm sorry. I don't want to make you feel bad. But when you write it down for me officially, you got to make them. They got to be equations of lines because that's how they show up. These lines. What situation are we in for the horizontal asymptote? The ha.
The bottom.
Oh yes, sorry.
So to find the y-intercept, you're just dividing 3 and -3, right?
No. If you use this form, in fact, why is this form easier? Because how do you find the y-intercept?
By dividing 24 and
No, why? How do you find the y-intercept always? You make x 0. If I make x 0 here, I have to do 8 times 3 and then 0, 0. I actually have to do work in this form. Do you see that? This form, I just have to do that.
because if you make all
Both forms, you're going to come up with the same answer. It's coincidental that 3 divided by negative 3 is negative 1, which is the right answer. It's coincidental. Do you understand?
Yeah.
Okay, cool.
Because if you make all the x's 0, you're just left with.
You have to actually work it out and then see what you're left with. Whereas this one, you can just see.
Okay.
Yeah. And real quick, guys, everybody understands this, right? This is this. This is this. That's why it doesn't matter which version you use. They're both the same thing. Yes?
So, when you ask us to find the asymptote, do we have to show any work? Or can we just say what it is?
Well, this is the work, right? Oh, for the horizontal asymptote?
For both.
Vertical asymptote, you have to do this. You have to factor. That's your work.
Mm-hmm.
And then you can just write them down.
Alright.
Horizontal asymptote, I don't know. It depends on how I ask it.
Y equals 0, isn't it?
Yeah, it's y equals 0. Why is it y equals 0?
Because the bottom degree is bigger than the top.
Yeah, the top degree is smaller than the bottom. Whichever way you want to say it. Everybody with me so far? Okay. F of negative 10. Let's see what that's going to be. 8 times negative 17 over negative 2 times negative 13. Whatever the shit that is. Is that negative 68 over 13, which is roughly something.
Like 5.23 something.
Say again?
Like 5.23.
25?
No. 23.
What's it started with? I'm sorry.
5.23.
Oh, 5 point.
Negative 5.23.
Okay, I'm sorry. I just couldn't hear. I'm sorry.
Oh.
Okay. So that's f of negative 10. So I know it goes through the point negative 10, negative 5.23. You don't have to be that precise. This is by hand, right? F of 5 is going to be 8 times 13. So pretty cool. I'm just plugging 5 in over 13. That kicks ass. Times 2, I believe, which is 4. Double check me on that. I don't trust myself today. If I plug a 5 in, 8 times 10 plus 3, 8 times 13 over 13, so the 13's cancel, times 2. So you get 4, yeah. Okay. So it also goes to the point 5, 4. Kick ass. All right, now take a minute. Try to set that up on the graph. So far, it was really nice. I want you to understand, if your y-intercept was 0, negative 24, you would have to make your scale so that you could reach that, right? But this one, we'll see what you think. We'll see what you do. You do have to get to negative 5.2, right? But, you know, I would kind of let you, if you want to do 5, that's fine. What about your x-axis scale?
2.68.
Yeah, I would go by twos.
Yeah, you have to go down to negative 10, so that'll work, yeah? Yeah, it'll work. All right.
Oh, sorry. I thought we only had to go to 8.
For what? Sorry.
Because I was only looking at the vertical asymptotes.
Ah, okay.
X, yeah.
But there's the biggest x thing. Yeah. Okay. But you're fine. That'll work.
Yeah.
All right, so negative 2, negative 4, negative 6, negative 8, negative 10, 2, 4, 6. All right, Jeff, they don't need to hear all this. Be all superficial X, Y. All right, so now you just start throwing shit on there, right?
Mm-hmm.
You can put your walls down there. And then your other walls, let's see. And then your last wall. Oh, I already did that. Okay. So here's a really good example. There's an asymptote on the x-axis, but we have x-intercepts, right? Because x isn't big yet. So let's see, negative 3 halves, that sucks a little bit. So here's negative 1, so negative 3 halves is going to be about right there. And y-intercept is 0, negative 1.
Yes.
Could be. What's the multiplicity of this intercept?
1.
All right, so we know it's got to do this, correct? Because there's the y-intercept. And it can't possibly go back up here because there's no x-intercept here, right? So I know it's got to do this. I know it's got to go through. So it can't do this. So yes, cactus. I sound like I'm like a yoga teacher, and that's a pose. Everybody
I know.
assume cactus.
3 Fs, be 1.5. No, negative.
Does everybody see that?
Yes.
Again, if I let you do one more point, you could plug in like -6 and see that it's up here, but you don't need to, right? Now I've got these regions out here, right? Now sometimes I will get an x-intercept out here, and it's not quite as unknown, but they're totally unknown right now, correct? So all right, I'm being silly. I already told you good points to use. I forgot. So normally right here I'd say, what should I plug in? So I could do that to you on a quiz or a test. I could just not do this step. And you have to know to plug in stuff. So why does it make sense I said f of 5? Because it's right here, and I got a 4 out. So do you guys know what it looks like over here?
Yes. It's positive.
True. So what's it look like? You can do it in the air. I like it. So it's got to approach the asymptote, and then it's got to approach. Oh man, it got a little wiggle. Wiggle, wiggle, wiggle.
So the point and the asymptotes are always going to tell us.
They're like bumpers in bowling, right?
Yeah, so
They sort of keep you. They're like you. There's only so many things you could do. So the minute you know walls and a point, there's only one option.
Okay.
Yeah. So over here, same thing. I said f of -10, -5.2, -5.2, and this is where I let us go a little bit off, so it's here. So then I know it's got to go. I don't know. You guys can't see this. So -5.2, right? And then it's got to go wee. So this is another situation where it takes this guy a little bit longer to approach. And again, you could throw that in your calculator and kind of make sure it works. Okay, I like it. Okay, last thing I want to do. Oh shit! All right, I can't. So I'm not going to be able to get in chapter 6. It's okay, Jeff. There's still a situation we haven't really discussed,
Which is if the top
and I'm
is
about to
bigger.
say something that will make you feel a certain way. It's going to be your favorite situation, kids. Yeah. Okay. What's the last situation for horizontal asymptote we have not addressed? We did talk about it a little bit.
If the top is bigger.
Top is bigger. Let's just do a quick example and we'll call it a day. Roughly on time this time, that'd be great. Yeah, if you could end the class on time, that'd be great, Jeff. Okay. So what if I had we're just going to focus on the horizontal asymptote because we're just making this shit up. Probably doesn't have nice x-intercepts, right? It's probably going to be gross, but too bad. Let's all suffer through this together. So, if the bottom degree is higher, it grows faster. The whole thing goes to 0 because I'm dividing by bigger. This is the exact opposite situation. Is the bottom able to keep up with the top?
No.
Therefore, the top is growing unbounded, so this does not have a horizontal asymptote. Unfortunately for you, it's not the end of the story. It does have a certain type of asymptote. In fact,
Oh yes.
real quick, I think I want to do this way. Don't even do, just sit there. Sorry. Stop, calculator. Just let me do shit. Okay. Give me 1 second. I want to show you what this looks like.
Diagonal pass?
Dudular.
Yeah, it's like a slant.
Slant, there you go. Sometimes also called oblique.
Oh, what?
Oblique.
Oblique, like,
Oh, yeah.
that sounds like the beginning of some kind of Edgar Allan Poe poem. Oblique, the morning begins. Okay, x squared. What's up?
There's an oblique muscle, right?
There you go. And you also have like lateral numbers, and you have lats and all. Yeah, all right. It's all just positional words. So let's just see what this thing's going to look like. What have I created? Ooh, look at that. It just did some weird shit. So let me do this. Let me close my x-axis in a bit because a lot's happening real close to the. Watch what it does. So it's got a little heartbeat because the poor little dude freaks out when there's an asymptote. Do you guys understand? There's going to be a couple asymptotes. Are they going to be nice? No. Vertical asymptotes. There's going to be a couple, and they're probably going to be really, really close. Do you notice something though? Do you see how this? All right, this is going to infinity over here, but it's going to infinity in a very defined way. So let me. It's not the best example I could have made, but too bad. So just don't even worry about this. Let me show you. If I long divide this. Oh man, what the shit, Jeff? All right, so everybody suffer for a minute. I'm just going to do this real quick. I don't trust myself today, but let's see what I do. Is that a 5, Jeff? Yes. Minus, plus. So I get negative 8x squared. This is so fun, Jeff. Okay. Minus 8x squared, minus 16x plus 8. Change. Then I get 22x minus, is that 9? I love it. So then I would put plus 22x minus 9 over x squared plus 2x minus 1. Now, real quick. What's important here is when x gets really, really big, that piece right there goes to what? This is a situation you know. This poor little dude, what situation is he in? The top degree is less than the bottom. So as x gets big, this goes to 0. So as x gets big, my function should follow x minus 8. Let's all see if Jeff did that long division correctly. Yeah, all right. So now if I look further out, sorry guys. Oh shit, just go there, Jeff. If I look further out, let's go to 20. Do you see how it's following that line now?
Mm-hmm.
And you can see why it's called a slant asymptote. You maybe don't, yeah, it's related to obliques from the body.
We have to find like a slope for that then?
Well, what's the slope?
Oh, we did.
It's a linear function, right?
Oh, yeah.
So y equals x minus 8, that's what I plotted here.
Okay.
So when you have to draw, you would actually graph x plus 8, and you would put a dotted line.
Okay.
Yeah, okay. That is plenty for today, guys, so.
So we have to long divide for those ones, for those problems?
Yes.
Are we still on 5.6?
Yes, that was, we just finished 5-6. Elena's not here. Alan? Here you go. Kumar. Khan?
What does he compare to the other one?
James?
Put them side by side.
Alexis?
It's swollen right around here, right around her ankle.
You know how that makes sense.
You know those.
I curved the test a bit. I don't think I.
No, but you know the thing
Put it
where
on your
like
test
you're just like walking and you like you step on a crack in your ankle. That's what happened with me. And then to avoid having people stop and watch me, I just kept walking.